Hi there, welcome to your third webinar. In this webinar, we're going to go through 4 different topics. At the very start, we will learn parts of speech tagging. In here, we will use analytical library, which it will make the whole process just a few couple of lines. And later on, you actually coded line by line in your project, which you will use hidden Markov model. Secondly, we will go through the lookup table, which in here we go through our text data and we count each word with its corresponding label, and we put these in a table using pandas. Thirdly, we will learn bigrams, which bigrams is literally same thing as a lookup table, but instead of going through text each word at a time, we go with a sequence of 2 words, a sequence of 2 labels. At the very last part, we will learn hidden Markov model in speech tagging, which this is just a warm-up, and it makes you ready to actually start your project. Okay, now let's get into the part of speech tagging part. In part of speech tagging, we want to take any type of text and we want to go through each of the words in it and actually predict which of them are noun, which of them are verb, which of them are adverb, and so on. And we want to tag each of the words in there. Unfortunately, NLTK already provided with some libraries for this, which it makes the whole process so much easier and faster. So let's start with actually pre-processing our text. This is our text, and in here we just go through three parts of the pre-processing, which we will first lowercase, then we will remove the punctuation, and at the end we will tokenize stuff. So let's start by lowercasing. It's printed text. Okay, as you can see, our text got lowercase. And now let's remove the punctuation. And for removing the punctuation, we use regular expression text re sub. And in here we say delete everything that is not lowercase letter, uppercase letter, and also the whole numbers. If you saw such things, replace it with empty strings. And we want to apply this on our text. Now let's take a look at our text. Okay, now as you can see, like all of our punctuation has got deleted. Okay, at the very last part, let's now tokenize our text, which we can do it simply by split print text. Okay, now we are ready to put this on our NLTK part of speech tagging. Now let's import it. TK, okay, NLTK dot part of speech tag, and in here we put our tokens. Okay, and as you can see, it was just a very few lines. We just at the start we pre-process our text and then we put on this one single line and we get all of the parts of speech tagging in here. And if you're interested to learning more about this, there's some further resources for you, so you can actually go more deep into it. Okay, now let's go to the second part of this Jupyter notebook, to the lookup table. In lookup table, we will imagine this is our data. We will go through each of the words in our data, and what we do is that we have a table, and for each row we write our words, each of the unique words, and for each of the columns we put our labels, unique labels. So in here we only have noun and verb, and in here we will count it. For example, Mary was only once here and it will appear as a noun. Or saw appeared twice here and both of them was verb. And we will actually count this. So now let's actually start coding it. And in here, this is our sample data, which I took it from here. As you can see, this is our text, and I also wrote down the labels. So the first thing we always do is just preprocess the data, and we can actually write a function of it. Preprocess, let's say text list, which is this, and also labels. The first thing we want to do is to, as you can see, this is a list of strings. This is multiple strings. What we want to do is just have only one string. So let's convert the list of strings into one string. And the way we do this is pretty easy. We just say join text list, and in here our text is going to be just one single string. So now we can actually start the preprocessing, which is lowercasing the text. We can do this text.lower. Then we can remove the punctuation. Is uppercase. We use a regular expression, but before that, first let's import it. That's so you can say everything that is lowercase, uppercase, and it is number, keep it. If it was beside this, replace this with empty strings, and we want to apply this into our text. Then we want to tokenize our text, which in here let's use actual NLTK. Say from NLTK dot tokenize import word tokenize. So tokens word tokenize that we just have imported it, and we will apply it into our text. So now all of our text has been successfully preprocessed. Now we want to also preprocess our labels as well. So let's do the same thing by converting the list of strings into just one string, which again we can do this simply by join. You can say labels, and let's also tokenize our labels as well. Labels word tokenizer labels. Now let's return it. Return tokens and labels. So this is our function. Now let's apply this to our text and labels. So preprocess text labels and tokens labels. Let's print them out. Tokens. Okay. Also, let's print out the labels as well. Okay, as you can see, at the very start, we just converted this list of strings into just one string. Then we lowercase them. Then we remove all of the punctuation, like this dot here. Then we tokenize our text, which this is the final version of this. And we also pre-process our labels, which we only did converting them into just one string, and since all of them are lowercase, then we won't apply the lowercasing or remove punctuation because it already has been somehow pre-processed. So after tokenizing, this is the last version of the preprocessed version that later on we will use this. So now let's count each of the tokens and labels. Let's write a function of it. And let's call it count. It will take in tokens and labels. And the first thing we want to do in each of the counting is to actually use a counter, which we can use the collection library, collection, import counter. This is very useful if you want to count any type of words. So let's first initialize it. Initialize the counter. You can call it CNT counter. And now we want to iterate through each of the tokens, and later on we will apply the counting. Say iterate through tokens and labels. Say for I word, I label, zip tokens that we got it from here, and also labels. So now we want to see if this I word and I label, is it inside counter or not. If it's not inside it, we make it equal to be 1. If it's already inside it, we just sum that up with 1. So let's say if word and label inside counter, and you can say easily if I word, I label in CNT. Also we have if word and label not inside counter. So if it wasn't inside the counter, we just put it equal to 1 because it's the first time we found it. You can say I word, I label equal to 1, and if it's already inside of it, we just want to sum it up with 1. I word, I label, and as simple as that. Now we apply the counting. Now at the end we will just return the CNT. Okay, now let's apply this into our tokens and labels. Say CNT count tokens labels. So let's print it out. Okay, as you can see, we got each of the words and its corresponding label, and we counted in our data set. And if you want to make a table out of this, which is in this version, one way to approach it is to just first initialize a 0 table, and then we will replace these values in their corresponding place. So let's now just make a zero table, and the way we do this is using pandas. So let's first import the library. Okay, we can say data frame, pd.dataframe. So we want to say that each of the rows be equal to the length of our tokens. As you can see, this is our tokens, and we want to be length of this be equal to these words. Okay, the way we do this is say length of np.unique, which this np.unique, it will only get the unique values in that list, and we want to apply this into our tokens. And for our columns, we want to do the same thing but with our labels, and we can simply say length np unique labels. Before that, let's also import the NumPy library, which I forgot. Okay, now let's take a look at this actually. Oops. Let's see what went wrong. Okay, I forgot to put the np.zeros. Take this, okay. And as you can see in here, we have 4 rows corresponding to our 4 tokens that we have, and we have 2 columns corresponding to only 2 unique labels that we have. Now let's actually change these index names and also columns names, so it would be more obvious. And we can do this by simply say columns, which in here we can apply the our unique labels, which, as you can see, it got our noun and verb. These two are unique into our labels, and it just put it in our columns. Now let's also change the index names, and we can say df.index, and same thing, list of np.unique, and we say tokens. Let's take a look at it. Okay, great. Now as you can see, now we already got our 0 table with each row corresponding the tokens and each column corresponding the labels. Now what we want to do is just replace some of these zeros with our values, and we can simply update it by first iterating through our counter. So let's write down, say list of cnt.items. So first we want to get the corresponding word, which if which if you take a look at I, let's just take a look at it. Print I break. For getting the word, what we are going to do is just delete this. Okay, it is first we say I0, which is equal to this, and we say we add one more 0 for getting only the actual word. And for getting the tag, instead of 0 we can say 1. So let's say get the corresponding tag as a label I0, which is equal to this, and we add the 1, which is equal to this. So now let's update it. We can say df with our label, and then word. In here we just make it equal to I1, which is equal to this. Okay, Now let's update and take a look at it. Okay, as you can see now all of our value got updated. And if you take a look at this table and also this, it is identical, and we applied all of the steps for getting the final result for the lookup table. And if you're interested for learning further, you can go to the resources and read it through. Okay, now let's go to the third part of this Jupyter notebook, which is about bigrams. Bigrams are literally same as the lookup tables, but with this difference that instead of going through our data word by word or label by label, we go in a sequence of two. For example, we go to Mary will see Jane, and we go like that, or noun model verb noun, and we go in this model. Beside this, everything else is same as the lookup table. So this is our data set, which as you can see I got it from this here. I wrote down the text, also their corresponding labels, and like always we will start by pre-processing our data, which let's now write a function of it. Process, say text list, which is this is a list of strings. We take this, also labels, which also labels are the list of strings as well. So we start by like before, we'll starting by converting the list of strings into one string, and we can do this simply by using join, say text list. And let's now also do the lowercasing, removing punctuation, also tokenizing. So lowercasing the text, which we can do this simply by text.lower, and we will also remove the punctuation, which we use regular expression, import array. So keep all of the lowercase, keep all of the uppercase, keep all of the numbers. Other than this, replace it with the empty strings, and we want to apply this to our text. Now we do the last part of the pre-processing, which is tokenizing the words. And we can use the NLTK, say from nltk.tokenize, import word tokenize. Okay, tokens word tokenize, and we put our text. So now our text data got pre-processed. We also want to do pre-processing for our labels too, and since this is all already lowercase and there's no punctuation into it, the only thing that we need to do is to first converting it to a list of converting into one string and just tokenizing it. So let's starting by converting the list of strings into one string, and can do it by join, say labels, and also we will tokenize our labels. Word tokenize labels. Now let's return it, tokens and labels. So let's apply this to our labels and tokens process, which is text and label, text labels. Let's print them out, tokens. Now let's go to another line, labels. Okay, now let's take a look at it. As you can see, we converted this text to the preprocess version of it, and also convert these labels into this. So the next step is to write a bigram function which only it takes tokens and it returns in a sequence of 2. So let's actually write it. Bigram, it takes tokens, and for making a token, there NLTK already have a function for it which we can use it easily. Let's import NLTK. We can simply say that bigrams that are equal to NLTK dot bigram. As simple as that. We just put the tokens in it. Turn bigrams. So now let's apply this to our preprocess tokens and also preprocess labels. Say tokens bigram. You will apply this function to it, and also labels bigram, which will apply to our labels. Now let's print out the result. Tokens bigram, which you want to print the tokens bigram. Let's go to the next line for printing out the labels bigram. Okay, bigram. I forgot to put a S at the very end. Okay, and since this is a generator, we can simply say lists, and it will bring the list of our tokens. So as you can see in here, we converted like Mary Will into this, then Mary C, then C Jane, then Jane Will, and we go in the sequence of 2. And now that we have our bigram, we need to count them to get these values, these 1 3 1 1 1 1. So we can, like before, we will use counter. So let's start by writing down our functions, which it will take the label tokens and labels. And the first thing that we want to do is to initialize the counter. Let's import it from collections, import counter. So we can call it CNT counter, and now we will iterate through our words and labels, tokens and labels. We can simply say for I word I label in the tokens and the labels that already provided to this function. Okay, now we want to say that if I word and I label already inside counter, and also if the I word and I label not inside the counter. So we can say if I word I label in CNT, I can say else. So if it wasn't inside there, we can simply just make it to be equal to 1. Let's copy paste this, and we can simply make it equal to 1. And if it wasn't inside of it, we can just make it +1, so it will actually count it. And we already done with the counting our bigram, so let's now just return it. And let's apply this to this bigram that we already got. So we can say bigram count, tokens bigram, labels bigram. Let's print it out. Okay, as you can see, it already got the bigram of our words and also bigrams of its corresponding labels, and it count each of them. So now we want to, as you can see in here, it says Mary Will. Now what we want to do is to actually convert this into this version. And the way we do this, again, in here we will use join, say words names dot join. Also, for joining this, since it is not empty, we will just put the dash. So let's now iterate through our bigrams. So which is in bigram count dot items. We iterate through this and we put just I. Now let's take a look at it. Words name, okay, let's see what's the problem. So in here, what we want to do is to actually get the names, this, it will iterate to the whole of this, to hold this. So what we want to do is say first I0, so we go first to this part, and then we will add another 0, which it will go to this part. Let's now check this out. Okay, as you can see, we converted all of these into two words that are stick to each other with a dash. So we want to also apply the same thing to our labels. So let's just copy paste that, labels name. And in here, instead of this 0, we put 1, which we want to take this. This is 1, this is 0. So let's print this out as well. Labels name. Let's also give it empty line. Okay, as you can see, we applied the same thing to our labels as well. So now what we want to, like before, is to just initialize 0 table, and then we will update our each of the values inside of it. So for making a table, we use pandas. So let's first import it. Okay, let's say df is equal to pd.dataframe. And in here we want to initialize zeros, which in each of the rows are equal to our tokens, unique tokens, which we can say words name. Also, I forgot, we want to be equal to length of it because we want to initialize the zeros. And then we also want the length of our column, the amount of our columns, to be equal to the length of our labels, which we say length of np.uniques labels names. Okay, let's take a look at it. Let's see what is wrong. p.0. In here we have to put another tuple. Okay, as you can see, we have already 8 unique tokens, which we already got it, and also we have 4 unique columns. So now let's change each of the column names to be equal to our labels. So the way we do this is to say df.columns is equal to np.unique of labels name. Let's take a look at it. Okay, as you can see, we updated this to our bigram labels. Now also let's change each of the rows. df.index, which will take the unique value of each of the word names. Okay, now our table is ready to be each of the value to get updated. Now we have each of the rows equals to the bigram words, and also each of the columns equal to our bigram labels. And we can simply update it by first iterating through our bigram count items. It's first printed to better understand again. Okay, so let's first get the corresponding word. We can take this by first we want to take 2 words and a dash be in between of it, so we can say dot join I. We start bit by 0, which will take this 0, then we put another 0 for taking this, and we will add another 0 for getting this. Now we have our word. Now let's get the corresponding label, which we again want to join them with dash. In here same as above, but at the very end instead of 0 we put 1, so we will get this, not this. Okay, now that we have both our word and label, we can easily update our 0 table. You can say in df label word, and we want to add it with this, which we can say I0 to get this, then I1 to get this value. Okay, now all of the values got updated. Let's take a look at it. As you can see, we already got our table, which this table is equal to this table in this image. And if you would like to learn more, there is resources for reading through it. Okay, now let's go to the last part of this Jupyter notebook, which is about hidden Markov model in speech tagging. If you already went through the videos in your courses about the hidden Markov models, you already know that every hidden Markov models consists of 2 sets of probabilities. The first part is a transitional probability, which is a probability in between tags. In this part, as you can see, all of these arrows indicates the transitional probabilities. The second set of probabilities in a hidden Markov model is called emission probability, which is a probability between each of the tags and the corresponding words. As you can see, these parts are all emission probabilities, and in this part we will code both of it. So let's start by initializing our model, and the way we do this is to actually use a library is called Pomegranate, which they already implemented the hidden Markov model for us. So let's import it, pom pomegranate. And we can build a model by saying pomegranate dot hidden Markov model, and we can initialize it. So let's firstly start by writing down our emission probabilities, and the way we do this is to first actually write down the distribution, like these probabilities. As you can see, the probability of model and will is 3/4, model can is 1/4, and we will write each of these probabilities and then we add it to our state. So let's actually start coding it for better understanding. And we will, in here we will write 3 sets of emission probabilities, one for noun, one for model, and one for verb. So let's say emission noun, we'll start by noun, and we say pomegranate dot discrete distribution. This distribution is just where we put our probabilities, the only numbers. Then we will add it to our state. So let's start by noun, and we can say Mary and noun is 4/9, and we will write it down. And the next word is Jane and noun is 29. And we will do the same thing for all of the words in here. Will is 1/9. Spot is 2/9. Can is 0. C and Pat are both 0, so we will set both of them to 0. Pat 0. Now that we have our distribution, what we want to do next is to make a state. Say state noun pomegranate dot state. Now we will add these emission probabilities. So we just say emission probability of noun, and we can also give it a name. Let's say noun. Okay, now we are done with writing down the emission probabilities for all of the nouns. We can do the same thing for the modal and also for the verb. So we can just simply copy paste this, and we just make some few modification. Like in here it is model, and Mary for model is 0, Jane for model is 0. So let's change this. 0, Jane is 0. Will for model is 3/4. So let's write this down. 3/4. Spot is 0. Can is 1/4. Okay, 1/4. And also C and Pat are both 0. So we will just leave this. And also let's make this, and also for the name we can add model. Okay, now also for emission probabilities for our model is done as well. Now let's go to the last part of the emission probabilities, which we do it for our verb. Okay, let's first change the names. Emission.verb, state.verb. Okay, now let's check each of these. Mary verb is 0, Jane verb is 0, Will verb is 0. So let's set this, all of these zeros. 0, 0. And spot is 1/4. Spot is 1 over 4. Can is 0, which is already 0. C is 1 over 2. 1 over 2. Pat is 1 over 4. 1 over 4. And also let's change the name to verb. Okay, now all of our emission probabilities are ready, and at the very end we want to add all of these states into our model, and we can do it by writing down add states, and we will write each of these states into it. Okay, state noun, state model, and at the very end state verb. So now we added all of our emission probabilities to our model, and now we are done. And we will start by second sets of probability, which is transitional probabilities, which, as I said, transitional probability is the probabilities in between our tags or labels. And we can do this by simply saying model.add transition, and in between we will just write down the starting point, the end point, and also the probabilities. That is it. So let's first say the add transition probability from the start tag to noun, a start tag to our model, and a start tag to our verb. This start tag we can write down by model.start, which is same as this. And for our noun we can say state noun, which we write it down in here, state noun. And the probability between the starting point and the noun is 3 over 4. We will write it down. And we will do the same thing for other states as well. So add transition model.start. Now let's take a look at the model, state model, which is 1 over 4. We can copy paste it for saving a little bit more time. Model.start to verb is 0. State verb 0. Okay, now let's go for the transitional probabilities from noun to model to model to verb, and also to the end tag. Okay, we can say model.add transition state noun, which state noun to state noun is 1 over 9. Copy paste this. So model dot add transition state dot noun to state dot model, which is 1 over 9, which is same thing. Okay, now let's add the noun to verb, which noun to verb is, oh I'm sorry, here state noun to state model is 1 over 3, and from state noun to state verb is 1 over 9. So now let's write down the transition probabilities from model to nouns to model to verb. So we can say model.add state, add transition, state.model, state model, which is 0. Let's copy paste this. Model to noun, which is 1 over 4, and model to verb, which is 3 over 4. Okay, now let's write down the transition probabilities from verb to verb, verb to noun, verb to modal, and also, okay, model dot add transition state verb state verb. Verb to verb is 0. Paste this. Verb to noun is 1. State noun. And verb to modal is 0. State modal 0. Okay, now, sorry, okay. Now at the very end, let's add all of the transitional probabilities that goes to the end tag, from noun to end, verb to end, and modal to verb. Okay, model dot add transition state noun model dot end. Model dot end is this, which from noun to end is 4/9, and from model to end is 0. State to model to end is 0. From verb to end is 0 as well. State verb 0. So now we write down all of our transition probabilities and also our emission probabilities. To finalize our model, we will just write down model.bake, which now our model is totally ready. We can now start to predicting. But before that, let's just get the total number of edges and our nodes. Let's say total number of edges, which is model dot edge count. Let's also print down the total number of nodes. Model dot node count. Okay, as you can see in here, we have 5 nodes. Let's check it. 1, 2, 3, 4, 5, and also 15 edges. If you count each of these arrows, you will see that there is actually 15. So there's one small thing that we want to change in here, that at the start we want to change the starting point to /s and /n, which on default is non-dash and non-dash start, which we want to change it. It is not necessary, but we want to just do this. You can say -1 because this is the end. We can make it equal to, okay. Now let's say model states to name to start. Okay, now let's actually visualize our transitional probabilities. We can do this by importing from helpers import show model. Okay, show model. So let's take a look at the start. We have to put our model, which is called model, and then we have to put our fig size, which is a figure size. Let's say 10, 12, and also we can also indicate the file name, which it will save it in your local storage, say transition.png. And also we can say show ends, which it will show these two true. Okay, as you can see, this is the same transitional probabilities as this, only the places are a little bit different. Okay, now let's actually predict. Let's get a sentence that our model never saw it and actually predict it. So this is the text we are going to work, and like always, first we're gonna do the pre-processing steps. So let's do this now. Text.lure. Let's remove this by regular expression. Before that, let's import the library. Import regular expression. So text re.sub. Let's keep all of the lowercase words, uppercase words, all of the numbers. If it was other than this, replace it with empty strings, and we want to apply this to our text. Also, lastly, let's also tokenize our data. Text.split. So let's take a look at it. Print text. Okay, this is a pre-processed version of this sentence, which we lowercase it, remove the punctuation, also tokenize it. For predicting our text, what we want to do is to write down model.viterby and put text. In this way, we are going to have two returns. First, viterby likelihood, and also viterby path, which we are interested in our path. So let's get the final viterby path. Let's actually take a look at this path. So as you can see, now we have a dictionary which a lot of information are irrelevant to us, and what we want to do to actually just get these names, these names. So to get the final version, we just will iterate through. Let's write down viterby path, and we will iterate through in our viterby path, and we just say that state.1, okay, and we will get the name of it. So as you can see, now we got predicted this sentence. Let's also print it, both of it. Print text, print viterby path, and as you can see, Jane got predicted as noun, will as modal, spot as verb, and will as a noun. And this is exactly the true prediction. If you see it here, like Jane is noun, will is modal, spot is verb, and will is noun. And we predicted correctly. So, and if you're interested for learning more, you can check out the resources. And also I included some notes. I went through all of the course videos, and I took a screenshot of all of the slides, and also write down comment below. So if you would like, you can take a look at these notes as well, which is a lot. And I hope you enjoyed this webinar. Thank you.